The following content is created by DrAvitech. Your support and donation will help me continue to offer high-quality educational resources for free. To make a donation, send an email to 6drcyril@gmail.com or comment donations below.
Welcome back, guys. My name is Dr. Avitech, and in this video, we want to talk about the Laplace transform of a constant. Now remember, I've earlier introduced this very course. Should I say this very course? This very subject. Is it a subject? This very topic. So I've earlier introduced it. And let's just get started. Remember to hit the subscribe button, like this video, and share it across to your classmates. Now, we want to take the Laplace transform of a constant. Remember, I earlier said that the Laplace transform of a function in t is equal to the integral from 0 to infinity. We normally call this integral a semi-infinite integral. It's not from negative infinity to infinity, it's just from 0 to infinity. So it's a semi-infinite integral. F of t e to negative st dt. So this is what we have. This is what we have. Now let's find the Laplace transform of a constant. Now what does this mean? This means we're saying let f of t be equal to a. So let f of t be equal to a, just some constant, you know. There's no t, just a is a constant. So what we're looking for is the Laplace transform of a. So this will be the integral from 0 to infinity. Now f of t here will become a. So this will be a e to negative st dt. All right, so this is what we have. I think I'm disappearing from the camera, so let me come to the side. Now, for integrals, remember, if you have a constant multiple, you can just bring out that very multiple in front of the integral. So in this case, a is going to come to the front. So this will be a integral from 0 to infinity, e to negative st dt. Yeah, we can do this. It's just a constant. We're supposed to integrate with respect to what? With respect to t. But as you can see, a does not have t. So it just goes away, you know. Now, this would be a. Now, what is exponential integration? How do we integrate exponentials? What we're going to be doing here is we're going to say we have e to negative st. So this is e to negative st divided by, when you differentiate minus st with respect to t, you get minus s. We're going to get minus s. Okay, let me kind of show you this. So we're going to differentiate, we have minus st. When you differentiate this, the t is to the power of 1. So you're going to have minus s times 1t, then you say 1 minus 1. So this will be minus st to the 0. So this will just be minus s. So that's why I have minus s there. And then my limits of integration would be 0 to infinity. 0 to infinity. So this is what we have. Again, remember, every single thing is with respect to t. That's what dt stands for. Respect to t. So the minus s here is a constant. So just bring it out. So this will be a over minus s. Nothing is going to be damaged. It's still okay. So this will be e to negative st from 0 to infinity. All right, at this point, I am going to be imputing my, what's it called? My limits into the expression. So this will become, let me just take this minus to this side. Let me just take it to the top. So this will be minus a over s. And then we're going to have e. When I put in infinity for t, this will become minus s times infinity, which will still be minus infinity or negative infinity. And then take away, when I put in 0 here, this will just be e to the 0. So you see that that's what we're going to be getting. And please, for the sake of the future, this very expression from this very portion, the value is not going to change. So I think from the third transform I'm going to be looking for, I think I'll just start, should I say, stressing myself about what this will give. You're going to see in the next example that this very value remains constant. So this will become minus a over s. Now what is e to negative infinity? That's actually 0. Now here's the thing. We have e to negative infinity. First, the laws of exponents or indices tells us that we can say 1 over e to infinity. We can actually do this. We can actually say, oh, we have 1 to infinity. And then this is still going to be infinity because, of course, you are raising something to the power of infinity. That's going to be so massive. All right. Now, what is this going to give to me? This very value would approach 0. You know, we're putting in limit here. So this very value here is going to approach 0. So we're going to put in 0. So this will be 0 minus, of course, anything to the power of 1. Sorry, anything to the power of 0 is 1. All right. So this will become minus a over s. And then 0 minus 1 is minus 1. Now, minus a times minus 1 is just a over s. So this will be the Laplace transform of a. That's just the Laplace transform of a. My marker is kind of faint. I don't know why. Now, remember to always put your screen, let it be HD. Like, let it be full screen. Because the board is large, so you can still see everything clearly. And you can turn on your quality settings to make the resolution much more better. Okay. Now that we've found the Laplace transform of a constant, let's just take a look at some examples. Just a few examples. So examples. 1. We're asked to find the Laplace transform of 4. Now 4 is a constant. So what will be the Laplace transform of 4? We know that Laplace transform of a number is that number divided by s. So in this case, this will just be 4 over s. That's just it. That's just it. It's going to be 4 over s. What of the Laplace transform of negative 2? Same thing. This will become negative 2 over s. 3. How about the Laplace transform of 4/5? Let's say we have 4 over 5. Now, what will this become? This is actually 4 over 5 over s. That's what it's going to be. 4 over 5 over s. But then, there's a better way of writing this. This will become 4 over 5s. Because this over 5 goes to meet the over s. They both collabo and stay together. So this is what we have. This is just the first example, the Laplace transform of a constant. So let's move into another type of example, another Laplace transform. I think this time let's talk about exponentials. So I'll see you in the next video. Remember to hit the subscribe button, like this video, and share it across to your course mates. Bye.